Hey guys, Mr. Thibodeau here. Just gonna go ahead and keep on trucking and whew, bad timing. All right, let's get to work. So if I alt tab over to here, okay. So we are still on lesson 1, course 2 for our math. We talked a lot about numbers, various things throughout here. And we are going to get down to our practice set. Okay. Let me try and find a way to make this. There we go. All right. What I did with my pen. All right. First question for practice set. Is this sign is incorrect. Okay. This one right here. Show 2 ways to correct the sign. Now, I'll be honest with you. When I first looked at this, I was like, what do you mean it's incorrect? It looks great. Then I, paid some attention, read the chapter, and figured it out. So there's 2 things that you could do to change this. Right now, it says that because it's specifying cents and it's using a decimal, it's saying that the lemonade is 0.45 cents, which the book tells you is not the intended amount for the lemonade. It's certainly a dirt cheap lemonade. It's less than half a penny per glass. There's no way anyone's making a profit with that. Though it's probably unlikely you're making a profit with 50 cents a glass in this economy. All right, let's try and actually get to work then. So there's 2 ways we can do this. We can rewrite this. The first is if we say 45 cents. Okay. And the other way is if we do 0.45, $0.45, right? It's only a decimal if it's talking about a dollar. One whole dollar is 100 coins. And it's only 0.45, it's only a decimal when we're talking about going up to that whole dollar. So 45 cents or 0.45. That would be the answer for A. B, name a whole number that is not a counting number. Now, I am actually not sure what they're trying to ask here. Some of this stuff is not stuff I use very often. Let's see what they're trying to get us to do here. What do they want here? So we are at practice set. This book is a pain in the butt to look through. Power of test, baseline test, practice set. Oh, 0. It's not a counting number. So it's a whole number that is not a counting number. Seems like some sort of riddle. All right, so they're looking for 0. All right. Where do they talk about that in this chapter anyway? Here we go. Including 0, the set of counting numbers forms the set of whole numbers. The number of set we call our counting numbers or natural numbers. We can show a set of counting numbers this way. All right, so that's where they're talking about it. All right, justify. When the product of 4 and 4 is divided by the sum of 4 and 4, what is the quotient? Okay, so this is trying to get you to think about product, sum, all those things. So when we're saying product of 4 and 4, we're saying multiply. 4 times 4, right? 4 times 4. That is a perfect square, which equals 16. Then we're talking about the sum of 4 and 4, which is 4 plus 4, which equals 8. And then it says what is the quotient. So when the product 4 by 4 is divided by the sum, so 16 divided by 8. Well, 8 goes into 16 2 times. So 2 is your quotient. Okay. All right. Number D, letter D, sorry. Simplify by adding, subtracting, multiplying, or dividing as indicated. Okay. So we got $1.75 here. We got 60 cents here. So it's a whole number, so be careful here, right? So this is, you can't see it, 1.75, and that's 60, but it's 60 cents. So we're going to write that as 0.60, and then we're going to add $3, which this would be incorrect, right? Because we've already established the points. So we're really going to do 3.00. All right. So now we just add all that together. 5 plus 0 is 5. 7 plus 6 plus 0 is 13. Decimal drops down. That one goes up. 3, 4, 5. $5.35. Okay. We'll go over to E. $2 minus 47 cents. Pay attention to your decimals. Well, you can't subtract 7 from 0, and you can't subtract 4 from 0, so we're going to turn this into a 1, that into a 10, then that into a 9, and that into a 10. 7 minus 10, that gives us 3. 4 minus 9, that gives us 5. That one drops down. 1.53 is our answer. All right, F. 5 is all cuddled up, nice and close to 65. Okay, 65 cents. We can leave it at 65 if you guys want to. It's just whatever we do. At the end, we have to keep that cent sign there. Or we can turn it into a decimal. Either way works. But we're going to go ahead and we're going to multiply this out. So you can try and do this in your head. I prefer to just move it over here like we're used to. So 5 times 5 is 25. 5 times 6 is 30 plus 2. So 325. Now we can leave it at 325 cents, or we can write it at $3.25. $3.25. Either way, this is a perfectly accurate solution. G. So 250 times 24. They use the dot this time instead of the more classic multiplication. The dot works, and they use the dot really. It came to prominence in algebra because you're using things like x in the problems when you're writing. And so by using a dot or the parentheses, it makes it a little easier to understand what's happening, as opposed to have both a multiplication symbol, and an X right next to each other, like which one's which. So this made it a little easier. All right, so 250 times 24. 4 times 0 is 0. 4 times 5 is 20. 4 times 2 is 8, plus 2, okay, is 10. Now for the 2, we're going to go ahead and drop down our tens, our ones place to start at our tens. 2 times 0 is, 2 times 0 is 0. 2 times 5 is 10. 2 times 2 is 4, and 1 more is 5. Okay. So now we have a total of 6,000. Okay. All right. So that is G. Let's go over here for H. 24.00. And we are dividing that by 5. 5 times 0. Oh, sorry. Dividing it by 5. Sometimes, Mr. Thibodeau, you got to pay attention. So let's rewrite this so that it makes more sense. Okay. Well, it's going to be a little tough. Let's see. 5 goes into 2 0 times. 5 goes into 24 4 times, which gives us 20. Subtract through that, and that gives us a remainder of 4. That 0 drops down. 5 goes into 4 8 times. 8 times 5 is 40. And we are left with a remainder of 0. That other 0 comes down, and 5 goes into 0 0 0 times. So our answer is actually 4 point, that decimal goes up, 4.8 times. So if you were supposed to divide $24 evenly for 5 different people, each person would get $4.80. Okay. Over here for I, we have 234 divided by 18. It's not a very easy one to write, so let's go ahead and let's switch it over to 18 divided by 234. It's also a little difficult to kind of manage, but I think we can do it. 18 goes into 23 one time. Okay. Subtract 23 from 18, or 18 from 23. It's going to go ahead and be 5. 4 comes down, giving me 54. Now, how many times does 18 go into 54? I don't know off the top of my head. So what I'm going to do here is I'm going to quickly go ahead. I'm going to do 18. I'm going to double it to get me 36. And then I'm going to multiply it one more time, or add another one. So this would be 18 times 1, 18 times 2. And then we'll see what 18 times 3 is. 454. Perfect. Okay. So I did this in my head. You can do it the longer way of multiplying it by each one to see how close we're going to get to that number. It's a little bit of a pain. It's not really elegant, but sometimes that's what we got to do. So 18 goes into 54 perfectly 3 times. So my answer is 13. All right, let's move on to J. Evaluate each expression for A equals 20 and B equals 4. Okay, so now you're starting to get into a little bit more of algebra, of this idea of variables, where you have an expression that says A plus B. And when we have this, these are numbers, or these are letters, right? A plus B, that doesn't make a lot of sense. But what we're doing is we're using these letters to stand in for certain numbers. That way we can change the equation and it can help us out. Most famously, you'll see things like E equals mc squared, which is energy times the mass times the speed of light squared. So the speed of light is actually a constant, but it's a really, really long decimal, really long number. So it's best if we just put C in its place. E and M, those change based on what's going on, okay, on the mass. So those are variables. So we'll have this equation which remains true, but changes based on what we're talking about. Another classic example is a squared plus b squared equals c squared. This is the Pythagorean's theorem. It helps us figure out the lines and the angles of triangles. We also have y equals mx plus b, which is another super valuable one. You're going to use this a lot in 8th grade. We use this for slope. And this is another one where all of these are variables and they change based on the equation. So we have this equation which remains true, but these numbers will change based on what we need. That'll make more sense later. Right now, it's just a plus b, and we are told that a equals 20 and b equals 4. So all we do when we see this, a plus b, is we're told what they mean, and so we just plug it in. Anytime you see a, you turn it to 20. Anytime you see b, you turn it to 4. And that's true because we are told literally for this problem that a is the same as 20 and b is the same as 4. So for these 4 problems, we will be treating anytime we see a as a 20 and anytime we see b as a 4. So 20 plus 4 equals 24. K has a minus b, which is really 20 minus 4, which equals 16. We'll jump over to this side here. I, which is a, b, and they're touching each other. Okay. Well, when they're touching like that, that means they are multiplying. Okay. So there's a little multiplication symbol there that's invisible. So we can do this as 20 times 4. 4 times 0 is 0. 4 times 2 is 8. And, oh, this is L, not I. Sorry. And M is A divided by B, okay, which 20 divided by 4. I happen to know that that's 5. You could also go ahead and do 4 divided by 20 and figure that out that way. All right, so I am full up on my page, so I'm going to switch over to a new page. So I'll do practice set continued. I just have a few more here. Write equations using the number 15. Okay, so n. So where 15 is the addend. So we have to remember what addend is, what's product, quotient, subtrahend, dividend, minend. Okay, so let's see, they started that over here too, right? That's actually what they start off with lesson in for the other class as well. Here we go. So we start off here. Numbers that are added are called addends. And the result is the addition is the sum. So if 15 is an addend, that means that 15 is being added to something. Okay, it's got the word add in it. Hopefully it should be easy. So 15 plus, we'll say, make it easy, and we'll say 5. That gives us 20. Okay. MN, you could do anything, 15 plus whatever, or whatever plus 15. You have lots of options here. Where 15 is the product. Okay, well, let's jump back here to see where it tells us the product is. Okay. Sum is the answer to two numbers being added together. A product is the answer when you have two factors multiplying together, two numbers that multiply together, it gives us the product. So in this, 15 has to be the answer to two numbers multiplying together. So 15. So two numbers multiplied together. Well, I happen to know that 3 times 5 is going to give me 15. MNO, we're at P. The quotient, again, we'll just go back here and see where it talks about it. It says the quotient is the answer of something being divided by something. So we'll do 30 divided by 2 equals 15. You could do 45 divided by 3, 60 divided by 4, lots of different options. 15 divided by 1 if you want to get cheeky. PQ, the subtrahend, okay, not a word I use often, but it's right here. In subtraction, the subtrahend is taken from the min end. So min end is the bigger number, you subtract the subtrahend, and that gives you the difference. So Q will do 45 minus 15 equals 30. Okay, 15 is your subtrahend. The dividend R, again, we have it back here. Dividend, okay, is the bigger number that's being divided by a smaller number. Usually, you can have a smaller number or divided by a bigger number. Gives you a tiny fraction. But in most of the easier examples, that's what we're going to do. So the dividend divided by the divisor equals the quotient. I also misspoke here too. The subtrahend is, the min end is not always the bigger number either. Okay. All right, so dividend divided by the divisor equals the quotient, and we need the dividend, right? Yep, so if you look here, the dividend is the number in the division sign. So we'll go ahead, let's put 15 in one of these, and we can go ahead and put 3 out here. Oops, sorry, my light went out on me. I guess I can just use this. Maybe that'll work better. Yeah. I don't love it. All right, we'll just finish up here. 3 goes into 15 5 times. My last question is S. The min end, again, we're going back here, and it's taken from the min end. So the min end is the bigger number here, minus the subtrahend equals the difference. So we have 15 minus 8 equals 7. Okay, that's just any examples. These will vary based on what you choose, but the 15 should always be in the same spot. All right, guys, I will come back with doing the written practice. I'm just going to do the odd, but that's your math for you.